Hello. In this video, I'm going to show you how to handle multiple variables, like more than two variables. So our example will consider macro variables from like 1962 through 2015, about five major macroeconomic variables like GDP growth, industrial production growth, consumer price index inflation, unemployment rate, 10-year treasury bill rate, right? So we have data. So look at this. It starts from 1962 January, like first quarter, and April, July, October, like every 3 months, up to the fourth quarter of 2015. So in total, we have more than 200 observations about five variables. So as I said in class, we are studying the covariance and correlation coefficient. So they are basically, these measures are designed to handle only a pair of variables. So when you have more than two variables, you have to use the measures for each pair of the variables, right? So there is no simple way to handle five variables at the same time. So I will show you how to make. I explained. So we have to make this table, it is matrix, right? So we will make a covariance matrix or correlation coefficient matrix. So to see five variables relations at a glance, right? It will tell you the covariances at the same time. So how to do that on Excel? Of course, you can use covariance dot as command repeatedly for each pair of variables, but there are too many, right? When you have five, you can think about 10 different pairs. So I will not do that. Instead, in one step, you can go to data tab. Oh, let me turn off my face and go to the data tab and data analysis. This data analysis, in case if you don't have this data analysis icon, you can install add-on, like you can search how to install add-on. I did that in earlier chapters. So data analysis add-on will, like if you click that, will show you these two options. Covariance and correlation. You can guess. One is covariance table and the other is correlation table. So let's try covariance table first. If you click that, input range, I will choose all the five variables at the same time. I will include the variable name, so I will check this labels in the first row. And each column is one variable group, so I will choose columns. And okay. Then you will see a table. This is already the covariance table, right? So you get numbers like that. It tells you, let me increase the font size. So the first, like this is variance of real GDP growth rate, right? The diagonal terms are variances. Oops. So diagonal terms are variances. These are variances because this is like say CPI inflation with CPI inflation. So covariance with the same variable is the variance. So these are variances. And the lower triangle numbers are the covariances for different pairs of variables like industrial production growth and 10-year treasury bill rate. They are correlated negatively, right? And CPI inflation rate and 10-year treasury bill rates are positively correlated with covariance 5.2. But again, remember, as I said in class, we can tell the sign, like it is positive, it's negative, negative, positive. However, the absolute value doesn't mean anything. Absolute value of covariance does not imply anything because it depends on the unit, right? So usually, I don't know, like industrial production growth has a higher variance, so I guess it has larger scale, right? So higher variance will increase the tend to increase the covariance, the magnitude of the size, the covariance. So only look at the signs. You cannot compare like 5.2 versus like zero point 0.4. They are not comparable. The scales are not comparable. Okay, then this is covariance matrix table. So as I said, you can tell the variance and the signs of the covariances, but if you wanted to compare which pair has a stronger or weaker relationship, you have to think about correlation matrix, which can be calculated in the same way. Go to data analysis, and go to correlation. Check correlation, click, and same input range. I just did Control Shift downward arrow like on Windows. So label, do the same thing. Basically, we'll choose the data, 5 variables at the same time, and I will check labels in the first row. Okay, then you get the same similar table, but now you see the scales are different. Numbers are now different. Not the same numbers before, but these numbers are um, between 0 and 1, right? So this will look much better if I do it like this. Okay, so then this is correlation coefficient. So the diagonal terms are useless because one means this is the correlation coefficient between real GDP growth and real GDP growth. Of course, they are the same variables, so they must be the same thing. It's correlation with myself, so it should be 1, right? So all the diagonal terms are 1, they are useless. But now you get standardized relationship. So it tells you about the strength of the relationship. So real GDP growth and the industrial production growth are very strongly correlated. Also, this is very strongly correlated. 10-year Treasury bill rate, interest rate, and inflation rates are very correlated. And also, negatively, this has the strongest negative correlation, unemployment rate and industrial production rate, which is natural, like, right? So now you can compare also industrial production growth is correlated more with unemployment rate than the inflation rate. So it is close to -1, away from 0. And this is the weakest, no. This is the weakest correlation. Real GDP growth rate and the 10-year Treasury bill rates are correlated, they are correlated with like about 0.02, which is really small, right? So you can now interpret the size of the measures. So in that sense, correlation coefficient can be more useful. Okay, thanks for watching, and I will come back with another example. Thanks.